Exercise number 4 asks us to use the table to solve the inequality 2x is less than 2. So it's giving us some values of x, and I'm going to add a column here. I'm going to add a true or false column. And so it's giving us these values of x that it wants us to plug into this expression. We've also got this inequality that 2x is less than 2. So the 2x is down here in the table. And then these x, where do these x come from? These are just random values of x that they're giving to us in order for us to see what values of x are going to give us true statements, to give us false statements. I wish they had added that box in there. I think that would have been a little bit more helpful, but we are adding that box ourselves. So what you need to do here, what we need to submit into this box is we need to do the expression 2x or 2 times x and substitute in the values of x that are given. So we've got 5 different values of x. We're just going to substitute them in for x. So for example, this first one is 2 times, and then x is equal to -1. 2 times -1 is -2. And so that's the value that we're going to put into the little box, -2. We're going to do the same thing for 0. 2 times 0 is 0, and so in this little box we're just going to put in a 0, and so on. And now with the true false, what I want you to do here, and you can do this on your own paper, is answer the question, is this -2 value, the value that we got, less than 2? And if it is, what you'll do is you'll put yes, that is a true statement. And then 0, is 0 less than 2? Yes, that is true. 1, when we do 2 times 1, that's 2. 2 is not less than 2 is equal to 2. And so that would be our first false statement, which probably means that anything greater than that is going to be a false statement as well. So what they're really wanting you to see here, what they want you to notice is that you are given these values of x, and some values are going to give you true statements, some values are going to give you false statements. We can use that information to determine the solution of the inequality. So you actually don't even have to do any math here, because you can see that -2 and 0, those gave you true statements. So that must mean that x can equal numbers less than 1, because that was the first number that gave you a false statement. Numbers less than 1, and you'll get true statements. So we would say that x is less than 1. How do we actually solve that out? Well, let me show you here. So if you don't reason through it, you can still just solve out the inequality. That's what it wants you to put here as a solution of x. You can still solve out the inequality by getting the x by itself. The only thing hanging out with the x is a 2, and it's a multiplication operation, so that means I need to use division to solve it. So I'm going to divide both sides by 2. And in dividing both sides by 2, I get 1x, or just x, is less than 2 divided by 2 is 1. The same kind of thing that we reasoned through at the beginning of this video, because we said that -1 and 0, those are going to give us true statements, but 1 is going to give us a false statement. So that means that x must be values less than 1, like 0 and -1. And so then that's the answer that you would put into the solution of the inequality. That's what it wants in that box. Exercise number 5. We're being asked to do the same thing with 5, 6, 7, and 8, 9, all the way up to 9. We're being asked to do the same thing. We're going to use the values of x that are given. And those values of x, we are going to substitute them into the expression of the inequality. So there's -3 times x. And then we're going to put whatever answer we get into these little boxes. So you're going to do it just the same way you did the last one. The solution for this inequality, this one's a little different because attached to the x is a negative number. And so we need to solve for x, which means that we need to get rid of that -3. Well, because this is a multiplication problem, we're going to use division to solve it out. And we're going to divide both sides by -3. I want to point out that you always have to do the same thing to both sides. So anytime you do something to one side, you have to do that same thing to both sides. So I'm going to put these both into the same color because I'm dividing both sides by -3. Even though this 3 is positive, what I'm trying to get rid of is this -3 on the left side, which means I need to divide by -3. And if I divide by -3 on the left side, I also need to divide by -3 on the right side. And that's going to leave me with x is less than or equal to 3 divided by -3 is a -1. And then hopefully in your head you were like, hold up, you made a mistake, because this should actually now become a greater than or equal to. Why? Because I divided by a negative number, which changed this 3 from being positive to now becoming a negative number. It's now a negative 1. And since it went from positive to negative, we also need to flip our sign for our inequality to still be true. And so it went from a less than or equal to a greater than or equal to. And then if we actually solve out the values that go in here and ask ourselves whether they're true or false, what we should see is that numbers that are greater than or equal to negative 1 are going to give me a true statement. Which numbers here are greater than or equal to negative 1? That would be negative 1, 0, 1, and 2. So I'm expecting to get true statements out of all those. And then negative 2 must then give me a false statement, because that's less than negative 1. So let's try it out. Negative 3 times negative 2, that's going to be a positive 6. Negative 3 times negative 1, that's a positive 3. Negative 3 times 0 is 0. Negative 3 times 1, negative 3. And negative 3 times 2 is negative 6. 6 less than 3? 6 is not less than 3, so that would be false. 3 is less than or equal to 3 because it's equal, so that's true. And 0 is also less than or equal to 3. That's true. And so hopefully you're catching the pattern that once we solve for the variable, that once we solve for x, what we're basically getting here is the answers of the table that are going to give us true statements. And then the solution, just as a reminder, the solution of the inequality is what goes into that second little box, the solution of this inequality. Alrighty, number 6. So number 6, same kind of thing. For number 6, we're going to be taking negative 6x. That's the expression that we're going to use. We're going to be substituting in these values of x from negative 5 to negative 1. And then for the solution, we are going to determine the value of x for the inequality x, negative 6x is greater than 18. For number 7 is a little different from the last 3 that we've seen. Number 7, instead of having the number like on this top one, negative 6x, which is negative 6 times x, we have here x over negative 5, or in other words, x divided by negative 5. So what that means is that any value of x that you substitute into this expression is going to be divided by negative 5, because the value that you're substituting goes up top, so that's negative 45, over the negative 5, which is the same thing as negative 45 divided by negative 5, which becomes a positive 9. Now, in solving out this inequality, I don't have the negative 5 on the top anymore like I did with multiplication. Instead, I now have it on the bottom. And so if the negative 5 is on the bottom of this fraction, what I need to do is I need to find a way to get a negative 5 on the top of the fraction, because any number over itself will cancel out to equal 1. So if this is a division problem, then that's my hint that what I'm going to need to use to solve it is multiplication. I'm going to need to multiply both sides by negative 5, because when we cross simplify, this negative 5 and this negative 5 are going to cancel out to become 1. And then essentially you're going to get x over 1, which is still just x. And if we multiply the left side by negative 5, then you should be thinking to yourself that we're going to need to also multiply the right side by negative 5. X is going to be on the left side, and then on the right side we have 7 times negative 5, which is negative 35. And then because we went from being positive to now being negative, by multiplying by that negative 5, we're going to need to also flip our sign. And so x is going to be values that are less than or equal to negative 35. Those are the ones that are going to give us true statements to our original inequality. Okay, on exercise 8, what I want to explain to you is how to input these fractions into this fraction or into this division problem. So what this is, we can look at it in two ways. What this is x divided by -1, and when we get to our first value, that is a fraction, we have -4/5. What you're going to do here is essentially you are just going to take this fraction and then just input it into this fraction. Just like that. So that -4, that's going to go on the top, and then the 5 is going to go on the bottom, is essentially all you're doing. And then instead of x, because we're substituting that in for x, we now have -4 over -1 times 5. So that's what you need to know, is that this is going to be, when those numbers on the bottom go together, they're being multiplied. Not added, not subtracted, but multiplied by each other. And so on the top, you'll still have just a -4, but on the bottom, you now have 5 times -1, which is a -5. And then this is already in its simplest form, but they're both negative, so I'm going to turn it into a positive 4 over 5. So let me show you a different way of viewing what we just did. So we started off with x over -1, and what we're doing is we are substituting this value into x. And this can also be written as x divided by -1. So x is equal to -4 over 5. So I just substituted -4 over 5. And then we're being divided by -1. Well, any number divided by 1 is still the same number. And then a negative divided by a negative is just going to be a positive. So we just get -4 over 5. So either way that you want to do it will work. On the exercise 9, we run into a little bit more numbers. We have run into a 3, which is something a little different than the number 1, which is pretty simple to divide by. But when we do this particular fraction right here for exercise 9, what you're doing is you're doing x divided by 3. And then x, in that case, for the third row, is going to be equal to 3 over 2, or 3/2. So same thing, like I said earlier, you can take this fraction and just input it into this fraction. So we could put, instead of x on the top, we're now going to have a 3 on the top. And on the bottom, we're going to add a 2, which means that we're going to multiply it by the number that's already there, in that case a 3. And then 3 over 3 times 2 is 3/6, which becomes 1/2. So just again, you're putting the top number on the top, bottom number on the bottom. If there's already a number there, then we need to multiply it out. And then just a different perspective of viewing it. If we did the traditional division, this would be x divided by 3. And then here we have x, we're going to substitute in 3 divided by 2. 3/2 divided by 3 is the same thing as keep change flipping and making this 3/2 times 1 over 3, which is going to be 3 over 6, which is equal to 1/2. So either way that helps you understand it is fine with me, however you do it. You can either just take the fraction that you're substituting in for x, put the top number on the top, bottom number on the bottom, and multiply any numbers that are already there. Or you could work it out traditionally and actually do the keep change flip when you're dividing. As long as whatever works for you works for me. And then just make sure to solve out those